So this question focuses on investigating whether a point is on the circle. So they're asking us to show that the point is on the circle, meaning that it is. Now, to solve this problem, we need to really assess what they're asking us here and what they're getting at. If a point is on the circle, so I'm just going to put it here, and that point is the point 5 minus 5 there. That means that that point satisfies the equation of the circle, and it means that that point is a distance of the radius length from the center of the circle. So there's two ways that you could tackle a problem like this. If a point is definitely on a circle, it satisfies the equation. That's the first thing we could do here. So instead of writing out this, I could try and write 5 squared plus minus 5 squared, and then I would have my minus 4 by 5 plus 2, so plus 2 by y, which is going to be minus 5, minus 20 then, and we can prove that the equation is satisfied. So what we will get is 5 squared plus minus 5 squared minus 4 by 5 plus 2 by minus 5, and then that's all going to be minus 20 then. And what we get is we get this all works out to be 0, so we get 0 is equal to 0, which tells us that that point is on the circle. There is another way that we could do this, and it's a way that we can think about points, whether they are inside, on, or outside the circle, and it's in the context of the radius. So if a point is on the circle, it is a distance of the radius away from the center. If a point is inside the circle, it is a distance less than the radius from the center. And if a point is outside, so for example out here, well then that's going to be the radius and a bit, so that distance is going to be greater than the radius. So I'm going to do this question as an example of that calculation as well. So what we would obviously need to get out then is information about our centre and our radius. So how do we find the centre? Well, this is the second general equation of the circle, and that will line up with our x squared plus y squared 2gx plus 2fy plus c is equal to 0. So what I can see from that is that my 2gx and my minus 4x are in line with each other, and I can see that my 2fy and my 2y are in line with each other, and I can also see, which might be helpful for later on, that c is minus 20. So what I'm going to do here then is I'm going to write that minus 4x is 2gx, and I can solve that, and I would divide both sides by x, and I'm left with 2g is equal to minus 4, so that means that g is equal to minus 2. There's g. Then I'm going to have 2fy and 2y, so 2y is equal to 2fy. We're going to then have that 2y is equal to that, so divide both sides by 2y. Let's speed up the process, and we're going to get 1 is equal to f in this scenario. Okay, I can also write down, just to see if that helps, c is equal to minus 20. That will be relevant in our calculations in just a moment. Now, the centre. For the second general equation of the circle, the centre is given by minus g minus f. That means that our centre here is going to be minus 2, which gives us 2, and minus f, which gives us minus 1. And if you're not sure where I got those, pause the video, go back, check on the values and what I was substituting back in. Now the radius, that is given by a formula. So because this is the second general equation of the circle, we are now talking about the radius as the formula g squared plus f squared minus c. That's going to be g squared, which was minus 2, squared plus f squared, which was minus 1 squared, minus c then, which is going to be minus 20. So I'm filling that all into the equation here, which is given in your log table, so you don't need to learn it off. We do just need to know how to read it and how to use it. So when I substitute that all back in, I'm going to have minus 2 squared, which is 4, plus minus 1 squared, which is 1, and then it's minus 20, which is plus 20. So I'm going to get the square root of 4 plus 1 plus 20, that's going to be the square root of 25, which is going to give me a radius value of 5. So really nice radius value there. Now remember what we said the connection between the centre, the radius and the point was here. If a point is on a circle, the distance from the centre to that point is the radius. If the distance between the point and the centre is less than the radius, if it's closer to the centre than a point on the circle, it's within the circle, and if it's outside the circle, we're going to get a value that's bigger than the radius itself. So now we need to find the distance between our point, which was 5 minus 5 here, so 5 minus 5, and our centre, which was 2 minus 2. So we're going to have 2 minus 1 rather. So I'm going to fill that into the distance formula, which is going to be x2 minus x1 squared plus y2 minus y1 squared. And we substitute into the formula then. I'm going to label them x1, y1, x2, y2. So let's call that x2. Let's call that y2. And we fill them in just accordingly then. So I'm just colour coordinating them to help a little bit to keep track of what's going where. So we've got our point and our centre going in here. So we're going to have x2, which we said was 2, take away x1, which was 5, square that, plus y2, which is going to be minus 1, minus y1, which is going to be minus 5, and square that. Now, simplifying that for ourselves, we're going to get 2 minus 5, that's going to be minus 3 squared. Then here is going to become minus 1, minus 5, that actually becomes plus 4 inside there, and what we will get inside here is the square root of 9 plus the square root of 16, square root of 9 plus 16, which is going to be the square root of 25, and the square root of 25 is 5. That value worked out to be the exact same as the radius value, so because the radius is equal to the distance, the point is on the circle.